Hey guys, Mr. Backerberg here. In this video, we're going to look at the terminology and notation of integration. Now, as we're looking at doing integration, remember that means that we're finding the area underneath some curve between the curve and the x-axis. And what we did before was talk about it in terms of a Riemann sum. So splitting that region up into all of these different rectangles, finding the areas of all those rectangles, and then adding all those areas together. So what we looked at doing was taking a limit as the number of rectangles approached infinity of this Riemann sum for our function. But as we start to do actual integration, there's a different way that we can talk about this. We're going to turn this limit of a Riemann sum into an integral of a function. Now, as we're looking at this integral, now this notation in here, we would read this as the integral of f from a to b. This elongated s symbol is our symbol for the integral. The a value at the bottom is the lower limit of the integration. The b value at the top is the upper limit of the integration. The function that we're dealing with is called the integrand. X is our variable in here since we're looking at this f of x dx, so that's our variable of integration. And when we find the value of the integral, we can say that we have evaluated the integral. In this example, what we're going to look at doing is taking a limit of a Riemann sum and rewriting it using our integral notation. So we're taking a look at the interval that runs from -1 to 3, and that's going to be partitioned into n different subintervals of equal length. So our delta x value is going to be 4 divided by that n value. We're going to let m sub k denote the midpoint of the kth subinterval. So we're going to take this limit and express it as an integral. So the first thing we've got is I'm going to draw in this elongated s symbol to represent our integral. I'm looking at this interval that runs from -1 to 3. -1 is the low value for the interval, so that's going to go on the bottom of the integral symbol. 3 is the upper value for the limit, so that's going to go on top of my integral symbol. Now this m sub k value we said was a midpoint of some k interval. All that means is that m sub k is representing some x value within one of those little interval chunks that we were talking about before as we were looking at creating these rectangles. So since that m sub k really just represents an x value, then as we're looking at this function down here, I can just replace that m sub k in both of these places with regular x's. So then our function that we're dealing with is going to be 3x squared minus 2x plus 5. Now we've got the delta x on the end to represent the change in the x, but as we're writing out this integral, we don't write out delta x, we write out dx. So this is the integral that we're going to be evaluating. We're evaluating the integral of the function 3x squared minus 2x plus 5 as we go from -1 to 3. Now, we haven't gotten to the point where we actually know how to evaluate these integrals yet. We'll get there eventually, but we're not quite there yet. For now, we're just setting up this integral. That's going to be it for this video. Thanks for watching.